Hey math kids, today we're going to talk about how to calculate probabilities by using the normal curve. So to start off, there's a figure in your book. Okay, once again, we're centered at mu. And then if we go one standard deviation in each direction, so 1 sigma is going to give us about 68% of our data. 2 sigma is going to give us 95%. And 3 sigma gives us almost everything. It's 99.7%. So what that means is if I just shade in this region right here, and if I shade in this region right here, if I take that green and that red and I add them together, that's going to give me 68% of my data. So what that means is the green's area is about 34%, and the red's area is about 34%. Okay. Now, if we go another standard deviation, so now we've gone 2 standard deviations away from the mean. We go 2 standard deviations away from the mean. I'll color that one white, this one purple. Okay, so if we do magenta plus green plus red plus white, that's going to add up to 95%. Now the specific value of just the white, it's going to be 14-ish. It's like 13.6. This is going to be 14-ish. Okay. Once again, it's 13.59. Now, if we go another standard deviation, let's see, I'm running out of colors. I guess I'll use yellow. And dark blue. So if we go dark blue, magenta, green, red, white, and yellow, that's going to be 99.7. So there's still a little bit that's not accounted for once we go to 3 standard deviations, but most of it is accounted for. And so the specific on that is going to be about 2%, and then there's a little bit left over. Okay, these are rounded, so it might not add up exactly to what we want it. However, that's how it works, and we're going to use that idea as we go forward. Okay, so our first example, a sample of cans of peaches was taken from a warehouse, and the contents of each can was weighed. The sample mean was 486 grams with standard deviation 6. Okay, so we're given the mean is 486 grams. We're given standard deviation is 6 grams. And so what we're going to do is we're going to make a normal curve. That looks kind of bad, but oh well. This is 486. And then if we go 1 standard deviation out, we're going to add 6 to that. And so if we add 6 to that, we get 492. And if we subtract it, we get 480. Okay, so we know that that's going to represent 68% of our data. Now it says state the proportion of cans that weigh 480 to 486. So it's asking specifically just about this area. So we know that that's going to be 34% from this diagram because it's the green area right there. And that's it. So we just say 34% weigh between 480 and 486 grams. Okay, the next one asks more than 492. So we got 492 right there. So it wants this area. Now basically what we're going to do is we're going to find the area of everything we don't want and then subtract it. So if we take just the second half of the normal curve, that's going to represent 50%. Then if we take just this piece, that's going to represent 34%. And so if we add those together, that's 84%. Now, we want the blue area, so we're going to take 100 minus 84, and so that's going to give us 16%. So 16% of the cans are more than 492 grams. Okay? Alright, I'm just going to erase this so I can keep that stuff on the screen. Okay. The chest measurements of 18-year-old male rugby players are normally distributed with a mean of 95 centimeters. So mu equals 95 centimeters, and we have a standard deviation of 8 centimeters. So if we do this normal curve, this is going to be 95, and let's wait to see what they want. So from a group of 200 18-year-old male rugby players, how many would you expect to have a chest measurement between 87 and 111? Okay, so what we're going to do is we're going to do our standard deviations and just hopefully it lines up with one of those numbers. So it was 87 to 111. Okay, so if we add 8 to this, we're going to get 103. So that's not 111. And then if we add 8 to this, we end up with 111. Okay? Now if we subtract, we get the 87 that we're hoping for. Okay, so we're looking for this piece, and this piece. Okay? And let's see how many. Okay, so first we're going to find the percentage of this, and so this is 34, and then 14. Okay, so we add those together, 68, 72, 82. So we get 82%. Now it said that we had 200 rugby players, so we just need to do 0.82 times 200. So that's just going to be 82 plus 82, so 164 is what we end up with. Okay. Once again, there are 164 players that have a chest measurement between 87 and 111 centimeters. Okay. Now the next thing says find the value of K such that approximately 16% of chest measurements are below K. Now if we look right here, this is about 16%. So it's essentially just asking us to go from here over here, and that's approximately 16%. And we can see on this diagram that corresponds to 87. So once again, I just took these. 14 plus 2 is 16, and that's essentially everything because this percentage right here is so small. And so approximately 87 is 87 centimeter chest measurement is what 16% is going to line up. Okay, so I'm out of time for making this video, so I'm going to split it into 2 parts, and we're going to come back and talk about how to do this with technology. So for now, calculator.